Hi, my name is Victor Ignacio Martinez Castro, and I'm from Toluca, Estado de Mexico. Before I start talking about my project, I want to talk a little bit about myself. She's my mother. She has been the pillar in my life, and also she has made me the man who I am today. In the other hand, my girlfriend has been there every moment for me, and it's the partner I've chosen to spend my life with. I love to spend time in outdoor activities with my brother and friends, and hanging out with my closest friends. The thesis proposal project I'm going to present is the metabolic flux analysis of astaxanthin for understanding its production in Xanthophyllomyces dendrotus. This is for obtaining the degree in Master of Science in Biotechnology. Is part of the graduate programs of the School of Engineering and Science, and my supervisors are the Professor Carlos Gomez and the Professor Rodrigo Balam. The form I will be presenting the project is first talk a little bit about the background, what is astaxanthin, what is Xanthophyllomyces, also which is the problem I'm going to be solving, and until now which is my hypothesis and research questions. Well, astaxanthin has several applications in the cosmetic industry, food industry, and aquaculture industry. In the cosmetic industry as an additive to the creams for preventing the oxidative stress, as an antioxidant for food supplement, and as a feed additive to the salmon and trout farms. This market is estimated that it will be worth around $1.8 billion around in 2019. Well, Xanthophyllomyces dendrotus is one of the microorganisms that synthesize astaxanthin, but it's a very complex process. Recent studies have fully sequenced the genome. This allowed to identify the genes that are involved in the synthesis of astaxanthin. Moreover, they already have been able to identify all the chemical compounds of the central metabolism and the metabolism of astaxanthin. And finally, they have tried from different angles to enhance the yields of astaxanthin production with modulation through limiting conditions, and from traditional mutagenesis to targeted genetic engineering of specific reactions. However, there hasn't been published a way to understand in a more quantitative manner the pathways that converge in the synthesis of astaxanthin. I'm planning to do this by stoichiometric balances and measure of intracellular fluxes through metabolic flux analysis. The basis of the metabolic flux analysis I will be performing is the next equation that it says the accumulation of certain metabolite is equal to the rate of formation of this metabolite minus the rate of consumption of this metabolite given by the product of mu specific growth of certain microorganism times the concentration of this metabolite. Finally, what I'm planning to do is a robust quantitative model that allow targeting more specific modifications of the via of synthesis, resulting as a more efficient usage of nutrients for the production of astaxanthin. Until now, the research questions that I've formulated is which are the rates of the main astaxanthin pathways and which are the formation rates of the essential intermediary metabolites for the synthesis of astaxanthin. For my part, that will be all. If there is any question or doubt, I will be happy to answer them.